places of the problem is not allowed to equal 0 in the denominator. So we're going to state our restrictions before we cancel anything out. So Q is not allowed to be, well, if I plug in a -3 here, -3 plus 3 is 0. So Q is not allowed to be -3, and Q is not allowed to be -1. -1 plus 1 equals 0. So Q is not allowed to be -1. So these are our restrictions. Sometimes they're called excluded values. Excluded. That just means we're going to throw them out. But they are part of our answer. Like if you were going to say, hey, you can plug in anything into this and make this true with the exception of these values. Now, we're going to go ahead and cancel. So cancel here and here. And so I end up with, now, we canceled everything out of the numerator, so I'm going to have to leave a 1 behind. And then Q plus 3. So all of this, where we've got our restriction. So all of this is my answer. So I have what I've simplified my fraction down to, as well as what my restrictive values are. Alright, let's look at example number 2. Example number 2, we're going to try to factor the top, we'll try to factor the bottom. The top does factor, it's one of our special binomials, two numbers that multiply to give me -144. But those two values have to add to give me 0. So I'm dealing with a +12 and a -12. This also works the square root method that I taught you guys. So this is going to be x plus 12, x minus 12. Now, out of the bottom, and a lot of you tried to slide and divide, this is not going to work here. I need you to think about greatest common factor. So I definitely have a greatest common factor of 3 and an x, so I'm going to factor that out. I'm going to do that here because I have a feeling I'm going to have to do maybe a little bit more, maybe not. So 3x, and then that'll mean I'll have x minus 12. No more factoring because that's factored as small as I can. So I'm just going to write it over here. So you can do work in other places, but then try to pull it all together in one spot. Now before we move on, let's state our restricted values. Alright, x is not allowed to be, now in this spot, if I put a 0 here, 3 times 0 times -12 ends up being 0. So x is not allowed to be 0, and x is not allowed to be 12. Because 12 minus 12 is 0. Alright, now we can cancel. So you always do your restrictive values before you cancel, because even though you're canceling something out, it still is in the original problem. So I end up with x plus 12 over 3x. Now I want to stop here and want to say that this is no longer able to be simplified. I will have a lot of people that will try to say, well, x over x, or 12 over 3, those are going to be able to cancel. And you cannot cancel because of that addition sign. You're allowed to cancel over multiplication, but you are not allowed to cancel over addition or subtraction. So because these two are being added together, or if we had two that are being subtracted, you're not able to break these up by canceling out pieces. It's not going to work. Let me show you an example. Let me get my final answer down though, where all that's true. So I will have people, and this is usually what I show when people try to do this. If I have 1 plus 2 over 3 plus 4. Okay, so what I'll end up having is I'll say, well, 1 plus 2 is 3 over 7, right? And they'll be like, okay, because you added and added. But then I'll say, okay, well, let's do where you cancel over addition. 2 over 4 reduces to 1/2. Right? So now you've got 2/5. Are these the same? And the answer is, of course, no, they're not. So you're not allowed to cancel over addition because you're changing these values that are being added and subtracted, and you're not really allowed to do that. You have to do the addition first. You have to do the subtraction, before you do this whole division idea of reducing your fractions. The multiplication is different. The one that we did with the 2/4 is different because those are not being added values. So because this plus or a minus is in here, you're not allowed to cancel just the pieces. So this is our answer, and that's our restricted values are part of our answer.